In this video, we'll look at a proof of a result 3.14. This will involve first looking at I guess what we'll call an axiom here. A product of a property of real numbers will come up. So we'll see that. So you can use that for other proofs. And we'll prove this and talk through a strategy of how to prove this statement. So looking at this statement, I see we're proving an implication again. P of x implies Q of x. So my initial assumption would be that x is a real number and that x minus 1 squared is less than or equal to 0. So again, just in terms of strategy, we're going to assume x is a real number and x minus 1 squared is less than or equal to 0. And we're going to try and show that 3x minus 2x squared is also greater than or equal to 0. So looking at my assumptions here, I have that x minus 1 squared is less than or equal to 0. Now, think about when you square a number, any real number, how could this possibly turn out to be a negative number, right? There's no way when I square a real number to get a negative number. It would have to be imaginary in order for this to work. So this is a property of real numbers. Property of real numbers, and this is going to help me prove my result. So this is what I mean by taking axioms. So it's okay we accept this as an axiom. We're not going to actually prove this property of real numbers. We're just going to take it as fact. We can prove it, but we're not going to go into all that. It's possible to prove this statement, but we're not going to worry about it. Property of real numbers, that if A is a real number, or I guess I'll write it like this, that A squared is greater than or equal to 0, right? When I square a number, it can't be negative, so it's greater than or equal to 0 for every real number A. So this universal property of real numbers. Another property of real numbers is when I square a number, well, if it was positive or if it was negative and I square it, then the result's going to be greater than 0. So the only way for A squared to be equal to 0 is if A is actually 0. So A squared is equal to 0 if and only if A is equal to 0. So we'll use these two properties of real numbers to help prove this result. Let's prove it. Proof of the result, not of the property. Result 3.14. So again, let x be a real number and assume x minus 1 squared is less than or equal to 0. And I want to get to this conclusion, 3x minus 2x squared is greater than or equal to 0. Well, since x minus 1 is a real number, right? If I take 1 away from real number, I'm still real. Since x minus 1 is a real number, x minus 1 squared is greater than or equal to 0. So I'm using this property of real numbers here. So I've used that in my proof. So this statement follows from the previous one because of this property of real numbers. So x minus 1 squared is both greater than or equal to 0 and less than or equal to 0. So I have 0 is less than or equal to x minus 1 squared. That's an assumption. And this is also, or sorry, that's not an assumption. That's this here, right? X minus 1 squared greater than or equal to 0. By assumption, x minus 1 squared is also less than or equal to 0. That's by assumption, right? This assumption. So what does this mean? That means x minus 1 squared has to be equal to 0. And I'd like to conclude here, right? I have a square of a real number equal to 0. So now I get to use this other property of real numbers, that a squared is equal to 0 if and only if a is equal to 0, to conclude that x minus 1 must be equal to 0. So x minus 1 is equal to 0. That follows from the previous by applying this property of real numbers. If x minus 1 is equal to 0, then x is equal to 1. Now I have something tangible to work with. I know that x is equal to 1, and so now it's very straightforward to show the conclusion. I just plug it in to this open sentence and show that it's true. So x is equal to 1, then 3x minus 2x squared is equal to 3 minus 2, that's equal to 1, which is greater than or equal to 0. That is, 3x minus 2x squared is greater than or equal to 0. And that's what I wanted to show, and so now I can conclude my proof. All right, in the next video, we're going to start working with odd and even integers. This turns out to be a really nice kind of playground for us to learn proofs, is with even and odd integers. And we'll see that in the next video. We'll prove another statement.